Thank you, Jim, and thank you all of you for coming today. I have a very, very simple point to make for you today, that because human material well-being depends heavily on access to abundant, affordable, reliable energy, and because fossil fuels are, and for the foreseeable future will be, along with nuclear, our best source of such energy, the demand to reduce our use of fossil fuels, to reduce our CO2 emissions, to reduce man-made global warming, amounts to a demand to reduce human material well-being. I'm going to illustrate that with 8 simple slides demonstrating the relationship between hydrocarbon fuel use and 3 simple measures of human material well-being. Infant and child mortality, which, as we shall see, falls with increasing hydrocarbon energy consumption and its concomitant CO2 emissions. Human life expectancy, which rises with increasing hydrocarbon fuel use and CO2 emissions. And income per capita, which also rises with increasing hydrocarbon energy consumption and CO2 emissions. The data in the first 4 slides come from the World Bank and other official sources as aggregated and graphed by the Gapminder World website. And the data for the next slide comes from Robert Zubrin, and the data for the 6th comes from the IPCC. So we begin in 1940. The first slide graphs CO2 emissions per person against child mortality in 1940. Each circle represents a country, the circle sizes indicating relative population, and the colors representing GDP per capita by nation, yellow being high, green, upper middle, red, lower middle, blue, low, and colorless, not categorized. The higher a circle falls on the scale, the higher the per capita emissions of CO2. Unfortunately, no. Technical difficulties make it so that the sizing doesn't work through this computer. So, the farther to the right the circle falls, the higher the child mortality rate. By that measure of human well-being, we should want to see the circles moving leftward over time, indicating declining child mortality. In 1940, for the vast majority of the world's people, CO2 emissions clustered under 0.5 ton per capita, and child mortality rates clustered between 200 and 400 deaths by age 5 per 1,000 children born. That is 20 to 40%. Higher emissions, lower child mortality rates, and higher income levels clearly correlate. When we come to 2009, we see the same information, but 69 years later. As we hoped, the circles have shifted to the left, showing declining child mortality rates. They have also shifted upward, showing rising CO2 emissions. In 2009, for the vast majority of the world's people, CO2 emissions cluster between 2 and 10 tons per capita. That is 4 to 40 times the 1940 levels. And child mortality rates cluster between 20 and 60 deaths by age 5 per thousand born. That is about 1/3 to 1/20th the 1940 rates. Higher emissions, lower child mortality rates, and higher income levels clearly correlate still. Now we'll compare 1940 and 2009 measures of human life expectancy. Here, the colors, sizes, and vertical positions of the circles represent income levels, population sizes, and CO2 emissions per capita, as before. But their horizontal location represents life expectancy. If we value human life, we want to see these circles shift toward the right over time, indicating rising life expectancy. So in 1940, for the vast majority of the world's people, CO2 emissions cluster still under 0.5 ton per capita, and life expectancy clusters between 25 and 40 years. CO2 emissions, life expectancy, and income, again, clearly correlate. Now remember, improvement in human well-being by this measure will be illustrated by the circles shifting to the right. What do we find? Well, In 2009, for the vast majority of the world's people, CO2 emissions cluster between 2 and 10 tons per capita, 4 to 40 times the 1940 levels, and life expectancy clusters between 65 and 75 years, about 60 to 300% higher than in 1940. Higher emissions, higher life expectancy, and higher income levels clearly correlate. As we hoped, the circles have shifted toward the right, indicating higher life expectancy. They've also shifted upward, indicating higher CO2 emissions per capita. Now this next slide graphs GDP per capita on the vertical scale as a function of hydrocarbon fuel use on the horizontal scale from 1800 to 2010, the years marked on the actual trend line itself. If we value human material well-being, we want to see GDP per capita rising. It does so only as hydrocarbon fuel use also rises. Now, hydrocarbon fuel use is crucial to overcoming poverty. World GDP per capita rises as global hydrocarbon fuel use rises. The call to reduce our use of carbon-based fuels is, by implication, a call to reduce our wealth. As of 2010, world GDP per capita was approaching $9,000, about a fifth of what it was in the United States at the time. To return to the 1990 level of hydrocarbon fuel use would be to cut world GDP per capita by about two-fifths of that. And to return to the 1970 level would be to cut it by about 2/3. Now this next slide reproduces a figure from the IPCC's fourth assessment report, the 2007 report, and shows that by the IPCC's coupled climate and economic modeling, the world's poorer nations, measured by per capita income, become richest at the end of this century and the next under the warmest scenario. Well, why does that happen? Because the climate models derive the magnitude of warming from the amount of economic growth. The reason they do so is that they assume the economic growth is to be driven primarily by fossil fuel use. The lower the fossil fuel use, that is, the more successful the efforts to mitigate warming by reducing CO2 emissions, the lower the economic growth, and vice versa. The higher the fuel use, the higher the economic growth. In other words, even according to the IPCC's own modeling, fighting global warming does more harm than good as measured by income per capita. Now, why is this important? Because of this simple insight. The wealthier you are, the more different climates in which you can thrive, and the better you are able to survive extreme weather. And the corollary is that the poorer you are, the less able you are to thrive in any climate, or to survive any extreme weather event. Now, these insights yield this implication. Since abundant, affordable, reliable energy promotes wealth, and nuclear and fossil fuels are now, and for the foreseeable future will be, our best source of said energy, those sources enhance human thriving and survival. And human thriving and survival are reduced proportionate to the reduction in human use of them. They also yield this further implication. Robert Zubrin's book, Merchants of Despair, Radical Environmentalists, Criminal Pseudoscientists, and the Fatal Cult of Anti-Humanism, is right. The climate alarmist movement, by advocating for less use of fossil fuels, implicitly advocates for less human thriving and less human survival. In other words, the movement, even when not explicitly, is implicitly anti-human. The primitive energy system dominant among the world's 1.3 or so billion people who depend on wood and dried dung as their primary heating and cooking fuels works this way, as it does in sub-Saharan Africa. The average sub-Saharan African woman spends 6 to 8 hours per day, leaving her precious little time and bodily energy for other productive activities to lift herself and her children out of poverty, gathering wood and dung as her primary cooking and heating fuel, smoke from which kills about 4 million a year, mostly women and children, and debilitates hundreds of millions for varying periods and at varying degrees because of the upper respiratory diseases it causes. The poor of this world desperately need to replace that primitive energy system with the modern one in which coal, natural gas, and nuclear materials are used to generate clean electricity delivered at scale through grids, not only for cooking and heating, but also for light and refrigeration and automated clothes washing and drying and computing and industry and business and commerce and healthcare. The campaign to fight global warming by reducing fossil fuel use is, at bottom, a campaign to retain the primitive energy system and its accompanying low incomes and high rates of disease and premature death. It is, in fact, a campaign of anti-humanism. It follows that such a policy should be taken only if its benefits clearly exceed its costs. And that can only be true if the amount of warming caused by our CO2 emissions is very high indeed. I leave it to others in today's program to demonstrate that that is not so. Thank you. Do I have time for any questions?
Time for a few questions for Kevin.
Be happy to field one or two questions. We're on a very tight time schedule.
All right, you have your
So nobody's going to ask me the embarrassing question, well, you've shown correlation, but what about causation? Correlation doesn't prove causation, right? All right, I'll ask the question for you. Well, without correlation, of course, there cannot be causation. With correlation, there might be. You have to have a causal mechanism to explain it. Well, the simple fact is that since everything we make and everything we make and move with energy. We make and move more the more energy we use. And coal, oil, and natural gas, plus uranium, being the densest forms of energies that we have, it is possible for us to generate electricity from those at far lower cost than from any other sources of energy. And since the law of demand in economics tells us that as price rises, consumption falls, and as price falls, consumption rises, the lower price, the lower cost of generating electricity from coal, oil, natural gas, and nuclear means that we will, in fact, use more energy using those than we will other sources. And since energy is a fundamental component of the price of everything that we make and everything that we move, therefore, we make and move more with more energy.
Thank you, Cal.